Thank you very much for joining me again. So we are going to continue on with logarithms, and now we're going to do some exercises in logarithms. Now remember, in the last lesson we discussed what a logarithm was. So a logarithm was another way to write an exponential. So this is an exponential, but we can convert it to a logarithm by writing it like this. So it's log, the base is 2, and then it's to the power of 3 is equal to 8. So 2 to the power of 3 is equal to 8. 7 to the power of 2 is equal to 49, and that's why x is equal to 2 here. So we're going to do some more exercises in relation to logarithms just so that you get familiar with them. Here are some simple ones. So let's begin. The first one, write log 4 base 4 to x is equal to 3 in index form, right? So we want to write this in index form, right? And so using that index form we can solve for x, right? So once again, if we look at our logarithms, if you have a logarithm like this, you can convert it to something like this. So 2 to the power 3 is equal to x. So 4 to the power 3 is equal to x in this case. So let's write that down. So here we've got 4 to the power 3 is equal to x, right? So a 4 to the power 3 is equal to x. What that means is x must be equal to 4 times 4 times 4, which is equal to 64. So x must be equal to 64. Let's do b. b, say, write 5 to the power of 2 is equal to 25 in logarithm form, right? So in logarithm form, we're going to need to write the base first. So this is log, and the base here is 5. 5 is the base, right? So log base 5 to the number, which is 25, would be equal to the power, because logarithms are powers, which is equal to 2. So this would be the equivalent of b. Okay. Let's do c. In c, solve log x 36 is equal to 2. Once again, we have to change it around. So you must change logarithms back to exponentials and exponentials back to logarithms to solve problems. Here we're going to change it. So the base is x to the power of 2 is equal to 36. So x to the power of 2 is equal to 36, right? So what that means is that x must be equal to the square root of 36, which is equal to 6, right? Okay, so some of you might be going, hang on, can't it be plus or minus 6, right? Because x squared is equal to 36, can't x be equal to plus or minus 6? And the answer is no, it can't be negative. That's wrong. And this is because what we said about logarithms was, if I have log a, base a, right, to y, a must be bigger than 0, right? That's a definition of logarithm. So therefore x must be equal to 6, not minus 6. Let's go to another one. D, sorry. So we look at D. Evaluate log 3, base 3 to 81. So we want to find what the value of this is. Remember, logs are powers, so this would be a power. So this would be log base 3 to some power, which is equal to 81. So let's say this power is x. So once again, we use our exponential. This means actually 3 to the power of x is equal to 81. Always use this circle to change it to exponential so you can understand it a bit easier. So 3 to the power of x is equal to 81. So 3 to the power of what gives you 81? 3 to the power of 4 gives you 81. Right? So x must be equal to 4. The last one, evaluate log 2 to 14. So this is e, right? So log 2 to 14, e. If we look at this here, this is log base 2, not 14, 1 a quarter. 1 over 4 is a quarter. So once again, if we use this same methodology, it's 2 right, to the power of x is equal to 1/4. So 2 to the power of x is equal to 1/4. What does that mean? That means that 2 to the power of minus 2 is equal to 1/4, because 1/4 is equal to 1 to the power of 2 squared, right? So therefore, x in this case must be equal to minus 2. So your answer for D, sorry to confuse the two answers here, but D is x is equal to 4, right? And for E, x must be equal to minus 2. Okay, we're going to continue on with a couple of more exercises. So let's move on for these basic exercises here. Simplify log x, log 8 to 1. So base 8 to 1. So what does that mean? These are some basic simplifications. So if you look at this, 8 to the power of x is equal to 1. That's how we will rewrite this. So what that means is, what is x? How does 8 to the power of what gives you 1? If you're confused about this, well, anything to the power of 0 is 1. So 8 to the power of 0 must be equal to 1. So what that means is x is equal to 0. Let's try B. So 8 to the power of something is 8. 8 to the power of something is 8. Well, that's one's quite easy. X must be equal to 1. 8 to the power of 1 is 8. C. If I have log 8 to the power of something is 8 to the power of 3. Well, that's straightforward. So 8 to the power of something is equal to 8 to the power of 3. You match the x with the 3, right? Because the base is the same. So therefore, x must be equal to 3. Let's do D. In D, we can see that log a to the power of ax. So if I have log a, right? So the base is a, right? To the power of something. Let's call this k, right? Is equal to a to the power of x, right? So if I wanted to simplify this, I'd be able to say that in this situation, k and x would be the same, right? So if I were to write this would be a to the power of something is equal to a to the power of x, so k must be equal to x, right? So I can rewrite this whole thing as just x. So log a to the x, k is equal to x. So this whole thing would be equal to, x, right? So the whole thing would be equal to x, right? So a to the power of x is equal to a to the power of x. It's straightforward. So this whole thing can be simplified as just x. Let's do E. E is 3 log to the base 3 to 7. Now remember, this whole thing here is a power, right? And this power will give you the answer 7. So 3, remember this is base 3 as well, 3 to the power of whatever this is should also give you a 7. So this means that the whole thing would be equal to 7. Okay, so let's make sure we understand. The brackets in green encompass a power. So 3 to this power will give you the 7. So therefore 3 to the same power, because the base is the same, 3 to the same power should give you the same number, which is 7. Alright, let's finish this off with the last one, F. So F is A log AX, very similar to E. So this is a general form of E, because here we use specific numbers like 3, but here we're not using any numbers, we're using letters. So if I've got a base which is the same base here, that means that I should have the same number, because this here, again, the log is the power. This power gives you x, right? So this power gives you x, because the whole power gives you x. Therefore, a to the same power should also give you the same number, which should be x. Okay. So these rules allow us to make some generalizations. The generalizations that we should make from this here is that if you've got anything to the any base to 1, so log of any base to 1, so these are your generalizations. Let's think about any base to 1. This should be equal to 0. It doesn't matter what the base is, anything to the power of 0 is equal to 1. The second generalization you can make, right? So the second generalization you can make is in relation to the second part, which is if I've got log a, so let's say I have log a, to a, that should be 1. Any base to the same number is 1. So a to the power of 1 is itself, right? So that's the third rule. The fourth rule you should understand is, the third rule you should understand is that if I've got log a, base a to ax, this is just x. And we did this here in D, right? And the last one you should understand is that if I have a to the power of log of the same base a, x, then this should just be x. And you can find this in rules E and F. I mean, the questions E and F show you the fourth rule. So to summarize, any log base to 1 is 0, right? Because anything to the power of 0 is 1. Any base a to itself is 1, because anything to the power of 1 is itself. Any base a, right, where the number is a to that power should just be that power. And any time that you take the same base with the same log with the same base, so the same power, a to the same power should equal the same number, which is x. If you're a little confused, just go through these examples here, and then you'll understand that these generalizations apply. Thank you very much for listening. I'll see you next time.